Section 2, we will introduce functions and function notation. Equations in two variables define relations between the two variables. There are other ways to describe relations between variables other than just equations. We could say set to set, so one set of numbers to another set of numbers, or ordered pairs where we have an x coordinate and a y coordinate. And we would say a set of ordered pairs is also called a relation. It relates the first coordinate to the second coordinate. Some relations are also functions. A function is a set of ordered pairs that assigns each x value to exactly one y value. So let's try a few examples. Given the relation, we have four ordered pairs, 4, 9, -4, 9, 2, 3, and 10, -5. We want to know if it is a function. So remember, the definition of function said we map one x coordinate to exactly one y coordinate. Basically, we can't have any x values repeated. So as we go through, we have 4, -4, 2, and 10. Because all of our x values are unique, we have no issues whatsoever. And so the answer is yes. This relation is a function because we do not have any x values showing up twice and going to different y values. Let's try another example. Again, we have a set of ordered pairs, 3, 3, 3, 4, 3, 6, and 3, 9. This relation will be a function as long as every x goes to exactly one y value, or we can't have any repeated x values. So as we go through, our first x value is 3, 3 again, 3 again, 3 again. Because 3 shows up more than once, it would not have to be the same x value every time. But because we have 3 mapping to 3, but 3 also mapping to 4, this is not a function. We might be given a set of ordered pairs, we might be given an equation instead. We'll be asked if the particular equation is a function. Now, because each element of the domain or the x values would produce only one element of the range, it is a function. One way that you could check this is to plug in two opposite values. Plug in x equals 1 and x equals -1. And we can see that those both map to the same y value, but they're two completely different x values. And every time we plug in one x value, we will only get one y value. In the second relation, we have x squared minus y squared equals 9. We want to know if this relation is a function. But because each element of the domain would correspond with two different values of the range, the relation is not a function. In this case, if we tried y equals 1 and y equals -1, I would encourage you to try to plug those in, or maybe y equals 3 and then y equals -3. We'll see that one x value actually maps to both of those particular y values. And because that's the case, we would have an x with two different y values, and it would not be a function. Another way to determine if a relation is a function is with the vertical line test. If no vertical line can be drawn so that it intersects a graph more than once, the graph is the graph of a function. If such a line can be drawn, the graph is not that of a function. So basically, we will have some graph and we'll draw vertical lines through the graph. If we ever touch the graph more than once, it is not a function. If we touch it at most once, it is a function. So let's use the vertical line test to determine whether the graph to the right is the graph of a function. So the graph we see is in red. And as we begin to draw vertical lines, let's count and see how many times we touch the graph with each vertical line we draw. Once, once, once. Every vertical line, we can continue to draw an infinite number of these, but every vertical line would result in one intersection. And since it never would touch more than once, this is a graph of a function. Let's just put yes. Yes, it is a function. Here's another example. Again, the graph is shown in red. It's a horizontal line. So as we draw vertical lines, we see that each vertical line intersects at most one time with the graph. Because that's the case, and again, yes, this is a function. Let's try one more time, and here we see an example where the vertical line test will fail. So we draw one line, and it will intersect the graph twice. Anytime one vertical line touches our graph more than once, it is not a function. Since the graph of a linear equation is a line, all linear equations are functions, except those whose graph is a vertical line. Also note that an equation of the form y equals a number is a horizontal line and is a function. An equation of the form x equals a number is a vertical line, and so by definition, it is not a function. When we speak about functions, sometimes we use a specialized function notation. And this is often used when we know a relation is a function and it has been solved for y. For example, the graph of the linear equation, y equals negative 3x plus 2, it passes the vertical line test, and so it represents a function. And we often use letters such as f, g, and h to name functions. And so when we name functions, we can sometimes use function notation, such as what we see here. The way this reads is f of x equals negative 3x plus 2. So we replace y with the symbol f of x, which is a specialized notation. That does not mean, this does not tell us to multiply f and x. It is just a special name that takes the place of y. When we want to evaluate a function at a particular value of x, we substitute the x value into the notation. So for example, f of 2 means to evaluate the function f when x equals 2. So we replace x with 2 in the equation. So if we looked at our previous example, and we had the function f of x equals negative 3x plus 2, and we wanted to evaluate f of 2, then 2 would take the place of x on both sides of the equation. Once we replace x with the number 2, we would simplify on the right-hand side and determine that the answer is negative 4. So when x equals negative 2, f of x, which remember took the place of y, would equal negative 4. And that's how we determine the ordered pair 2, negative 4. The x value is 2, f of x, or the y value would be negative 4. So let's try to evaluate a function at a specific location. Given that g of x equals x squared minus 2x, find g of negative 3. Then write down the corresponding ordered pair. So remember, this negative 3 takes the place of our x value. So in our function, on both sides of the equation, we replace x with negative 3. And then we solve. Negative 3 squared is a positive 9. Negative 2 times negative 3 is positive 6. And 9 plus 6 is 15. So we have g of negative 3 equals 15. And at this point, again, the number inside the parentheses, that was our x value we substituted. The number on the other side of the equation, the answer, that's our y value. So if we want to write the corresponding ordered pair x comma y, we would write negative 3 comma 15. We can also find the y values given function notation in the graph. So given the following graph of the function, find each function value by inspecting the graph. Remember, the numbers in parentheses tell us the x value. So we will use that x value and then find the corresponding y value. For instance, with f of 5, we go over on our graph and we find 5. 1, 2, 3, 4, 5. And then we go up or down until we find the corresponding y value. So if we go up 1, 2, 3, 4, 5, 6, 7. So the y value that corresponds to 5 is 7. Likewise, we want to find the y value that corresponds to x equals 4. So again, starting at the origin, we go 4 units to the right, 1, 2, 3, 4. We then go up 1, 2, 3 units before we get to the graph. So 3 is the corresponding y value. F of -5, we would move 5 units to the left of the origin. 1, 2, 3, 4, 5. And then we would move down 1 to get to the graph. So the y value would be -1. And last, let's find f of -6. Starting at the origin, we move 6 units to the left. We would then need to move down 1, 2, 3, 4, 5. It appears that it's -6 is the corresponding y value. The domain and the range of the following relation also determine whether the relation is a function. And when we're given something like this and we have a set of values that are called the input and a set of values that are the output, input represents x values, output represents y values. Now if we follow the arrows, we can create 4 ordered pairs. 1 maps to 2, -3 maps to 2, 5 maps to 2, and 100 maps to 2. Anytime we have a set of numbers, we put those in the curly braces like this. Now remember, a relation is a function as long as we don't have repeated x values. When we look at our x values, 1, -3, 5, 100, none of those are repeated. It doesn't matter that we use the same y value every time. There are no repeated x values, so the answer is yes, it is a function. In this case, the domain represents the x values, so we would write d, or the domain is 1, -3, 5, and 100. So all of the x values. The range represents all the y values, which we only have 1, so we just write 2. We don't want to write 2 4 times. Anytime a value is repeated in the domain or the range, we just write it once.